Hi, Dave Whitlock in Klamath Falls, Oregon, and I'm going to do a demonstration of the ice piston actually working. So in the previous video, when I showed you with the jar and everything else, there's one thing I would like to add to that, which is that if you put it on its side with the piston aligned at the top, just pack some frozen peas around it to keep it there. That will allow you to put more water in the balloon if you want, and might get better results. So other than that, it just has to be watertight. So this one, I'm going to show you let me see, I'm trying to coordinate the camera. Oh, here we go. Okay. The plunger is down at the 400 mark. I'm not sure if you can see that or not, but I put a Sharpie line. There's two Sharpie lines you'll see there, one at the bottom of the plunger and one at the top of the plunger. It's a coincidence that the plunger is about 1/4 inch thick. So I'm going to take this and a piece of dry ice. That's why I'm wearing the nice thick black gloves. So the dry ice, and I'm going to put that right against here. Love that little scream that it makes because of that. And I hope you can see the piston okay, because I'm just going to hold this here. And hopefully the insulation of my gloves will be enough. And I don't know if you can see, I'm going to move this in closer. It's slow. This is a thermal engine. We're building an apparatus to go around this so that it'll switch back and forth, hot, cold, when the piston hits top, bottom. And, just see how fast this one will go. But we don't have that yet. And anyway, with thermal engines like that, as they're going back and forth and building up kind of their balance, what you get is that they're very slow at first, and then you find out their top speed, because they will absolutely self-balance. Okay, I can see it rising from the line, so that's nice. And the gloves are still doing their job quite well. It's so much easier. I can imagine that it's so much easier to play around with coming up with this kind of technology right now than it would have been a couple of 100 years ago when maybe it should have been discovered. But now we can get dry ice at the corner store. We can get insulated gloves. This is a fantastic time. Wow, it is going fast. Usually, a couple of times I've run this and I've actually timed it on the first stroke. It was about 3.5 minutes. And that's what we're up to. Actually, I guess yeah. And so I can talk to kind of fill the space while it's doing its job. But it looks to me like we're getting kind of near the top line. I don't want to go past the top line. I've got 2.5 centimeters of water inside of this containment, which would allow me to go let's see, 1/2 inch plus 1/8, so 5/8 of an inch. But I'm only going to take it to 1/4 inch. And if you'd be so kind as to grab the boiling water, because we are just about at the top line, and my gloves are about at the end of their insulation. My fingers have gone from feeling wet to feeling cold. Dry ice is not your friend, so make sure you wear good gloves if you're going to do anything with it. And we are at the top line right there. So now I'm going to set the dry ice aside. And matter of fact, while I've got this like this, I'm going to go ahead and show you with a flashlight that there's, oh no, it doesn't look like it shows up on the camera very well, but there's nothing in here but liquid. It's just, this is clear sheets of Lexan that have been bonded together with methyl ethyl ketone, and for some of the layers with marine epoxy from a marina. And inside is just water and ethyl glycol. So we're still holding at the top line, and I've got a nice pot of boiling water here, or it was boiling. And so what we're doing is the dry ice is, oh, it's like -80, something like that. Let me see if I can rotate this so you can see it better and still keep it in the water. Can we see that? Can we see the lines? Yeah, we can see that we're off the lines with that, with the flashlight. And it's coming back pretty good. Oh, wait a minute. I'm just not getting a good angle here, and I want to get the best angle I can for you. So, there. And so, of course, ice melts, but it takes a little while for the heat to travel down the silver to the ice. And it has to deal with the temperature of the lexan and so forth. Like I was saying, with thermal engines, it starts out really slow, but in a little bit, if I kept going back and forth between the hot and the cold and the hot and the cold, what it would actually do is build a temperature gradient through the lexan, with one side being warm and one side being cool, so that the hot and cold coming in via the silver move faster. And this is visibly moving, I have to admit it. I love watching this thing. I swear I can do this all day long. Keep in mind that here on Earth, most of Earth, we're going to have to use solar ice making technology, which is based on Einstein's only patent. We're going to have to use that as a source of cold, but in the Arctic circles and upper atmosphere, or on an airplane moving through, upper atmosphere, you'll have all the cold you need, and we're back at bottom. But places like Mars and the moon, the most important point, in my opinion, is that Mars and the moon and the asteroid belt, you've got all the heat from the sun and all the cold from, well, it's space, it's cold. And every one of those rocks is a great, great heat sink, thermal sink, it's cold. You're going to have everything you need to freeze and thaw water and generate electricity, drive machinery, mine the asteroids, build colonies, build cities, broadcast back to Earth. Everything that we need. Okay? Run with it. Do it. It's yours.